So this is question 17 from the exam review. I'll do this by request. Just get set up, make sure it's all working. Okay, so question 17. We're given a function. This is what we're working with. 3x plus 1 parentheses times y. X is the quantity of good x that is bought, and y is the quantity of good y, so quantity of stuff. The price of good x is $3, while the price of y is $4. If the consumer has $31 to spend, so that's a constraint. These are going to be parts of the constraint, right? On goods x and y, use Lagrange multipliers to find the consumer's optimal utility level. So we're trying to maximize what they can buy. We've got the function here. It's our f of x. We're going to look over here. So that's what goes. So I pulled up the template for Lagrange multipliers. And you're not able to use these on the exam, but hopefully they're helpful in getting you to see how to place it, and then practice it without this. But maybe at the beginning it'll be helpful. So we've got 3x plus 1 times y. We're going to have to do we might have to do a power rule, right? Not a power rule, a product rule. So what might be nice is just I guess we still might have to, but we could distribute this y through. So to me, I think that would look nicer. Let's see if I can. Good, it's erasing, sort of. So I'm going to rewrite this. I'm going to distribute the y through. So this will be 3xy plus y, because it's just, to me, going to be easier, I think. Gxy, so that's where we got to set up the constraint, right? So each x that we buy will cost us $3, so that'll give us 3x. Each y that we buy, or they, will cost them 4y, and they only have $31, so this total cost of what they're buying, unless they got a credit card in their pocket, it's got to be less than $31 or equal to. So that's the constraint we're working with. The other two constraints, so that's a single one. I mean, obviously x is going to be greater than or equal to 0, so is y. You can't buy negative things, but all we need is 1 for that. Now, the Lagrange multipliers is done in terms of equals. So I forgot about that. So yeah, they could spend less than this, but I guess they want to maximize because we're looking to maximize their utility. You probably all know what that is more than I do. It's business theory stuff, but I guess they're trying to get the most stuff they can get, right? So let's go ahead and call this equal to 31 would be the most we could get. Again, we need this to be equal to 0, so we're going to subtract 31 from both sides. Right, that gives us 0 over here, and it gives us 3x plus 4y minus 31. Okay, so that's our g of x. 3x plus 4y minus 31. Okay, so now we need to set up our Lagrange multiplier formula, which we have here. And again, you have to know this for the test. It's not going to be on the test, but basically we've got two functions. One of them is equal to 0. That's the constraints. The other one is sort of the objective function, what we're trying to do. So that's going to be 3xy plus y. That's the f of x part there. Minus lambda, which is the Lagrange, that thing, times 3x plus 4y minus 31. So that's kind of multiply through, just easier for me when I go to get the partials. 3xy plus y minus, let's see, this was an x, 3 lambda x. Remember, lambda is a constant, it's a number. distribute the lambda through the negative lambda through, so we're going to get negative 4 lambda y, and then a negative times a negative gives us a positive, although again we're going to take the derivative. This is going to be 0, so sometimes if we make a mistake along here it doesn't show up, but we try not to make mistakes if we can, because we don't know sometimes, right? All right, now it's time to take the two partial derivatives, and the reason we do this is they will give us the tangent lines at a particular place. And what we're going to do is we're going to set them equal to 0, so we get horizontal tangent lines. Horizontal tangent lines are where they are indicating there's either a max or a min there. Usually there could be a few funky things, but that's how we find max and mins. So we take the L function, the Lagrange function. I think I like Lagrange more than Lagrange, but I use them both. Anyway, the Lagrange function, derivative with respect to x. Let me change into blue. 3xy. So the derivative of x is 1, so what's left over is 3y. Derivative of y is 0 because y is a constant, so that's gone. Derivative of negative 3 lambda x is going to be negative 3 lambda because the derivative of x is 1. Derivative of negative 4 lambda y, that's 0. Derivative of 31 lambda, that's 0. Okay, because that's all. So this is all we got left. We're going to set that equal to 0, but I guess I do that down here. Let's go ahead and get the partial with respect to y. So I come back to my function here again, do the same thing, but I'm going to take the derivative with respect to y. So 3xy, its derivative of y is 1, so the leading term is going to be 3x. Plus y, derivative of y is 1, so that's a plus 1. Derivative of negative 3 lambda x, that's all a constant, that derivative is 0. Derivative of negative 4 lambda y, derivative of y is 1 times negative 4 lambda. And then the derivative of 31 lambda is 0 because it's a constant. Okay, we set them both equal to 0. And okay, we just do that. Give myself some room. 3y minus 3 lambda over here equals 0. Sorry. 3x plus 1 minus 4 lambda equals 0. Now solve one of these equations for lambda. That's the key part. Substitute in the other equation. So let's do that here because I could see this 3y minus 3 lambda. This is going to be the easiest one to solve for lambda. I'll just add 3 lambda to both sides. So that's going to give us 3y, negative 3 lambda plus 3 lambda 0 equals 3 lambda. Divide both sides by 3. Oh, this is kind of nice. We get y equals lambda. What we're going to be able to do is now when we write the one over here, using this one, we're going to replace lambda with what it's equal to, y. So we write this one as 3x plus 1 minus 4y equals 0. So we're solving simultaneous equations, and this is how we do it. Now we solve this equation, that one right there, for x or y, and then we substitute back into this original equation up here, and we write it in its form where it's equal to 0. Okay, and then we will solve for whatever we got. I don't know which one's easier. Let's maybe I'll add 4y to both sides. Just I don't like to deal with negatives, as you know this. So then I'm going to get 3x plus 1 equals 4y. Divide both sides by 4. Just divide the whole thing. You could do 3/4 x plus 1/4 if you want, but I'm going to do this as a single thing. So that's what y is. And then, okay, solve this for, so I think I have that in the A. And solve the gx equation for the variable, plug it back into the equation in part A. To solve for the second variable, finally, so I made this, I'm not quite sure how to use it. What do I want here? I want, now solve this new equation for x or y, and then substitute it into g of xy equation equals 0. Yeah, let's see if well, I'll just go through, plug this back into the equation in part A. Okay, so I think A needs to be this. I think it was just sort of copy it down. B is going to be, we're going to substitute in y. We're going to substitute this in for y. So we've got 3x plus 4 times 3x plus 1 over 4 minus 31 equals 0. So now I think this is what I intended to do. We're going to solve this b part for x because it's only got an x. We will then substitute the x back in here, solve for y, and then we'll be good to go. So I should have started a little higher, because if I move it now, I think with this thing, yeah, the writing doesn't stay in place. So we're going to take advantage of some open real estate over here. Notice the 4 divided by 4, that's going to cancel. So let's just change colors. So I'm going to come all the way over here, and we're going to have 3x, right? That's that 3x there. The 4's have canceled, so what we are left with is plus 3x plus 1, that's the numerator, minus 31 equals 0. It gives us 6x, 1 negative 31 is minus 30. Oh, that's good. It's nice and divisible. Add 30 to both sides. Sometimes we end up with fractions and decimals. That's okay, but a lot of times they make it nice for us using nice numbers. So I added 30 to both sides. Divide by 6. We get x equals 5. Okay, so that's one value. Let's see, what are we trying to get? And then we got to get the z too. We got to get the y first, so we take this one over here. 3x plus 4y minus 31 equals 0. X is 5, as we just found out. And so now we take 3 times 5 is 15, plus 4y minus 31 equals 0. 15 minus 31, that's going to be 4y minus 16 equals 0. Add 16 to both sides. 4y equals 16. Divide both sides by 4. Y equals 4. So far we've got the point 5, 4, and then z. And that's what we're supposed to write our answer as. So we just need z now. How do we get z? Well, we come back to the objective function. So it's kind of a circular thing here. We plug in 5 for x, 4 for y. So we get 3 times 4 times 5 plus 5. It's 20 times 3 is 60. And then 60 plus 5 is equal to 65. And I think, I didn't look in advance, but let's take a look. I think I've got the answer key. It's a little bit of a mess, but 17, if we go all the way down to the answer key, let's just check, because if it's It's not right. I'm going to start over. 17. 5 units of good X. They didn't. Oh, they didn't ask for it. 4 units of good Y. Okay, so they just wanted the 5 and the 4. They didn't want what we're going to maximize out at. Gives us 65. I don't know what the 65. Maybe 65% happiness. I don't utility. But anyway, yeah, we have the 5x 4y correct. And then they didn't get on us. I guess I have to go back to the original question, not necessarily from my template, which is a little, again, it's not the, it's, well, it's there. Use it if it's helpful. It's not real clear, and like I said, it wasn't even real clear what I was doing here, but the first time I went through it made a lot of sense, so I labeled these, but then I couldn't remember what I did. Use the granular multipliers to find the consumer's optimal utility level. So I guess their utility level will be 65, right? Because that's what this is giving. But they really just wanted what was X and Y, and we got that. Okay, so that was 17. Send me any more requests. I do have a fairly full day tomorrow, but if you need anything reviewed, let me know. All right, take care. Good luck.